Hey everyone, in this video we will understand about the CLOOK disk scheduling algorithm. So before this, let me tell you, I have made a full playlist of the operating system and you can find that playlist link in the video description below. Okay, and you can find the other videos of the C programming, lead code solutions and other computer science topic also on my channel. So do watch them. So in the last video, we have already discussed about the various disk scheduling algorithm, that is FCFS, SSTF, SCAN, CSCAN, and the LOOK algorithm. If you have not watched the videos of these algorithm, you can find the link of these videos in the operating system playlist in the video description below. So do watch them. And in this video, we are going to understand about the CLOOK disk scheduling algorithm. Okay, so let's start. So basically, CLOOK disk scheduling algorithm is a modified version of our LOOK algorithm and the SCAN algorithm. And we have already discussed LOOK and SCAN algorithm in the previous video. So in LOOK and SCAN, what we were doing? So in SCAN, we were saying, okay, let's say we are moving in some, let's say, particular direction, let's say from lower cylinder number to, let's say, highest cylinder number. Okay. And we were saying, okay, from the current position of the read write head, just scan the request. First go in one direction, then go in the other direction. Okay. Then reverse your direction. Okay. And then again reverse your direction. Okay. So in this way, we were servicing the request which were coming in the direction of the you can say read write head. Okay, so in scan we are actually completing the request in this direction, then there, then there, then there, right? Now in scan we are going to, you can say, end cylinders also, although last request was this, but we are going here also, right? Let's say last request was like 80, then also we were going to 100, although 100 was not present in the, you can say, request queue. Okay, so in the same way, if the last request here was like, you can say 2, then also we are going to 0. Okay, so in LOOK we said, okay, you just revert the direction from 80 only. Okay, and in the same way, just reverse the direction from 2 only. Okay, because this is the last request that is coming in the request queue. Okay, so these all things will be present in the CLOOK, but we will not service the request in the back journey. So what does it mean that we are not going to service the request in the back journey? So we will see that this is somewhat related to our previous algorithm. In CSCAN, we saw that the same thing was there, that we were not servicing the request in round trip journey. Okay, so let's start with our example, and with the help of example only, we understand what does it mean. And then we will be able to better analyze this algorithm and understand this. Okay, so let's see. So basically in the previous video, we saw the LOOK algorithm. So we applied the LOOK algorithm on this example, right? So in this example, we were given the request queue. We were having 200 cylinders, that is from 0 to 199. And the initial position of the read write head was at 53th cylinder. And we were coming from the previous cylinder, that is 26. Okay, that means we were like going in this direction. Okay, from lower cylinder number to high cylinder number. So when we applied the LOOK algorithm, we saw we were going to 53. Okay, then we went to the last cylinder number, that is 183 according to this request queue. Okay, and we will not go to 199 in LOOK algorithm. Then we reverse direction and then we completed 37 and 14, right? Okay, so like we are scanning the request, we are going in this direction, then we are again going in this direction. Okay, we are completing the request in both the direction like the scan algorithm, but we are not going to the last request. Okay, so this property is similar to like LOOK algorithm. Okay, now in CLOOK, what basically we will do, we will say, okay, we are coming from 53. Okay, we will go to the last cylinder number, that is 183 according to our request queue. Okay, this is the last cylinder number 183. Okay, after that we will change our direction. Okay, in CLOOK. Okay, but in CLOOK, what we will do, when we will change the direction, we will not fulfill any request. We will simply come from 183 to 0. Okay, we will come to 0 and then again we will start from this direction and then we will fulfill the request 14 and 37. That is, we are completing the request only in one direction. Let's say we are going in this direction, so we will complete the request in this direction only, in this direction. We will not complete any request in the back journey or the return journey. This was the meaning of that we are not servicing the request in the back journey. Okay, so let's apply this CLOOK algorithm on this example. Okay, so let's here apply, and let's say again we are moving from lower cylinder number to higher cylinder number. This is the direction of the read write head. So initial position or the current position is 53. So here we have the 53, that is read write head. So we will complete all the requests till 183 as usual, as we have done in the look algorithm. So we completed 65, okay, then 67, then 98, right, 98, then 122, 124, okay, and last is 183. And after that we will simply reverse our direction as we have done in the look algorithm. Okay, we will not go to 199. So basically we will reverse our direction. Now in reversing our direction, in this direction we will not satisfy any request, we will not complete any request. So we will simply go, so basically we will go till 14. Okay, although I have told you that we will go to 0, okay, we will not go to 0, okay, that was my mistake. Okay, so basically from 183 to 14 we will go, because in my look algorithm we are going to the request only which are present in my, you can say, request queue. So same way in C look we are going till 183. When we reverse our direction, okay, we will simply go to the request which is present in this look algorithm. So basically if you see in this direction, this 14 is the, you can say, minimum cylinder number that is in this path. So we will simply come to 14 directly, and we will not complete any, you can say, request in this path. Okay, we will stop here. Okay, but as we have seen in our, you can say, CSCAN algorithm, when we were reversing our direction, we were coming to 0. Okay, you can watch that video of the CSCAN. Okay, in that we were coming from like 199 to 0. Okay, but here we are coming from 183 and to this request 14, because 14 is present here. Okay, let's say if 0 is present here, okay, in this request queue, then only we will go to 0. Okay, we are not saying that we will not go to 0, but if 0 is present, then only we will go to 0. Okay, if not present, that's okay, we will simply go to the minimum cylinder number which is present here, right? Okay, now after 14 we will reverse our direction, and now in this direction only we will fulfill the request. So basically when we will reverse our direction, 14 was completed as such. Okay, 14 we were present here, 14 will completed, then we will complete 37. Okay, so this is our C loop. Okay, so we completed the request in this direction only, in this direction only. We are not completing the request in this direction. Okay, okay, so what will be the total number of head movements? So in this, if you see, from 53 to 183 we have 133. Okay, 130, the same thing we saw in the look algorithm. Now from 183 to 14, these are the total head movement, 183 minus 14, okay, that is 169. And then from 14 to 37 we have this difference, that is 23, right? So we got 322 cylinders traversed in the C look algorithm. And if you see here, you can see 53 to 183, that was the same as here, and 183 to 14, this is same here also. Okay, but after that we are not adding anything, because all the requests has been serviced. Okay, so you can see this 37 minus 14, this is the extra, you can say, head movements in C look algorithm. Okay, that is 23 more, that's why we got 322 cylinders. Okay, so yeah, what will be the average head movement? So 322 divided by total number of required divided by 8, so it will be 40.25. Okay, now let's reverse our direction and see if direction is this. Okay, then what will be the answer of the total head movements? Okay, so same example, and we reverse our direction here, right? So when we applied the look algorithm on this example, then we saw we were getting 208 cylinders traversed. So basically from 53 we were moving, and we were going to the, you can say, last request in this direction, that was 14, and after that we change the request and we service the request in this direction, right? Now in C look we will basically move from 53 to 14, then we will reverse our direction, but we will actually not complete these requests in this direction, right? We will complete the request only in this direction, this direction, this direction, right? Okay, let's apply. So from 53 we will go to 14, 53, then 37, and then 14, 53, 37, and 14. All these requests were completed. Okay, now we will reverse our direction as we are doing in the look algorithm. Okay, in this reversing our direction, we will basically go till the last cylinder number that is present in your request queue. Okay, so what is the, you can say, maximum cylinder number? Okay, maximum cylinder number that is present in your request queue, this is 183. So we will basically go to 183, okay, and then we'll stop here, okay, or you can say now we will reverse our direction so that we can fulfill the request, okay. So now we reverse our direction, and what are the requests that will be coming in this path? So we will see 98, you can say, then 122, 124, 65, 67, all these requests will be coming, okay. So all these requests which were serviced in the look algorithm in this direction only, they will be fulfilled in this direction while we are applying CLOOK. So you can say 183 is serviced, then 124, okay, then 122, okay, and so on. So we completed all the requests, okay. So yeah, like scan, we are scanning the request, okay, and like look, we are just going to the last cylinder number as it is present in our request queue, okay. So these are the total number of head movements, okay. 53 minus 14, then 183 minus 14, okay, and then 183 minus 65. The total will be 326 cylinders traversed, okay. And here we have only 208 cylinders traversed. So basically, if you see, we have these number of more cylinders traversed in this CLOOK, okay, that is 118, okay, and here we have only 39, 169. 39, 169, 208, okay. So you can see 118 more cylinders traversed in CLOOK algorithm, right? Okay. Accordingly, average head movement will be 326 divided by total number of requests, that is 840.75. So I hope you have understood this example, okay. So if you have watched my video of the CSCAN algorithm, then you can see that in that video we were basically going from 53 to 0, okay, then 0 to, you can say, 199, okay, and then from 199 we were going to 65, okay. So in CSCAN, you can say we were going to the, you can say, last cylinders, okay, last cylinders, that is end cylinders. But in CLOOK, we are not going to the last cylinders or the end cylinders, okay. We are just going to the only those cylinders which are actually present in my request queue, okay. So you may ask that if CLOOK has the more number of head movements than the look algorithm, then by basically we are understanding the CLOOK, or what is the advantage of the CLOOK algorithm? So this is the same question that you can ask in while we are understanding the scan and the CSCAN algorithm. In the CSCAN algorithm also we saw that there were more number of head movements than the scan algorithm. But why did we introduce the CSCAN? So we introduced the CSCAN so that we got uniform waiting time of the request. So this was the example that we discussed while we were saying that why we introduced the CSCAN algorithm. So in the scan algorithm, actually the requests which were coming in the middle, they were getting the advantage, right? Because either we come from this path or either we come from this path. The middle request will get, you can say, completed earlier than the requests which were at the ends, right? So you can watch the video of the CSCAN for the detailed discussion, okay? So to So to make the waiting time of all the requests, whether they are at the end or whether they are at the middle, okay, for that we introduce the CSCAN algorithm, okay. So that's why we were saying, okay, if you are going in this direction, okay, always complete the request in such a way you come in this direction, then you just come here only, and then you start from here only. Do not service the request while you are coming in this other direction, okay. Start from here only, okay. That's why we introduced the CSCAN algorithm to make the waiting time of all the requests uniform, okay. So same thing we are doing in the CLOOK algorithm. So finally, if we talk about the difference between the look and the CLOOK algorithm, so basically look algorithm serve the request in both direction. That means in look we were going in this direction, then we were coming in this direction, and in both the direction we were fulfilling the request. But in CLOOK, if we are going in this direction, so we are completing the request, okay, but when we are coming or we are reversing our direction of the head, then we are not fulfilling the request. Then again we are starting from here and we are completing the request. So we are completing the request in only in one direction, right? That is the meaning of this first point. And if you see the throughput, okay, then we will see that the look algorithm has the higher throughput than the CLOOK. So what does it mean? So throughput, you can say that how many requests are completed per unit time. So basically, if you are saying that in CLOOK algorithm, we were having like more number of head movements. So basically, if you say ki, the time it takes from moving from one track to the another track is like 1 hour, okay, let's say from 53 to, you can say, 52, if I am going, then it takes 1 hour. 52 to 51, it will take 1 hour. So in that sense, if I move from 53 to like 65 according to CLOOK algorithm, okay, then total we have 326 vendors we have to traverse. So that means 326 into 1 hour, we have to, you can say, we will take 326 hours to complete or to fulfill all these requests, right? But for the same example, in look, we will take 208 into 1 hour, that is 208 hours to complete all the requests. So here you can see all the requests, they are getting completed in lesser number of time, okay, or less time, right? So that's why look algorithm has the more throughput than the CLOOK algorithm. That is the meaning of the second point. Now the same thing or the same question you can ask, then why we are introducing the CLOOK? Okay, so this is the main thing, that is in CLOOK we have the uniform waiting time or the response time of the request. Okay, if we are starting from like here, okay, then we are saying, okay, in the next time again we will start from here, we will start from here, okay. But in look we are saying, okay, we are starting from here, let's say in this direction, okay, and then let's say some request come here, then also we are saying, okay, we will come to you, but we will first complete these requests, okay, these requests, then we will come to you, okay. So these requests will wait like for longer period of time, right, although they have come very earlier, right, okay. So in that sense, the waiting time and the response time, okay, in what time we are responding these requests, that is non-uniform, okay. In look, the requests which are at the, you can say, middle, they are having the less waiting time and response time than the requests which are at the ends, okay. So that's why we introduced the CLOOK disk scheduling algorithm for the uniform waiting time and the response time, okay. So I hope you have understood all the algorithm that we have discussed. So please like and share this video, and also tell me your suggestions and the feedback in the comment box, okay. Your feedback and the comments help me to make the content better, okay. So if you have not subscribed the channel, please subscribe the channel, press the bell icon for further notification of the videos. So we'll see how we can implement all this disk scheduling algorithm using the C programming in the next videos. So stay tuned and let's see you in the next video. Till then, goodbye.